Number 12 says find the value of x, then list the angles and sides from shortest to longest. So we have two different tasks here. We need to find the value of x, and then we'll list our angles and our sides from shortest to longest. Where is x in the picture? At what? At all three angles. X is part of the expressions for the sizes of these three angles. Notice they all have degrees on them, so we're talking about our angles here. Well, we know that the three angles of a triangle add up to how much? 180. So I could start writing an equation. It says the measure of angle M plus the measure of angle N plus the measure of angle O equals 180. What could I substitute in the place of the measure of angle M? 7x plus 2. Drop my plus sign down. What can I substitute in the place of the measure of angle N? 8x minus 3. Drop my plus sign down. What can I substitute in for the measure of angle O? 5x plus 1. We're going to set that equal to 180. All right, so now we're going to combine our like terms together. My like terms would be 7x, 8x, and 5x. That's the first group of like terms. What do we get when we add 7, 8, and 5? 20. So I get 20x. And then we're going to combine our other like terms, our constants, the pieces without the x's. I have 2, -3, and 1. 2, -3, and 1. 0. So I have 20x plus 0 equals 180. Well, that's just 20x equals 180, because if I subtract 0 from 180, it's just 180. So then I need to divide both sides by 20. Divide both sides by 20. And that means x equals what? X equals 9, yes. All right, so we did the first thing we were asked to do, find the value of x. Perfect. Then it says list the angles and sides from shortest to longest. Well, if I'm going to put the angles in order from smallest to biggest, I need to know how big the angles are. So what can I do to find that? Yes, so let's substitute in. Let's do angle M first. The measurement of angle M is equal to 7x plus 2. So I have the measurement of angle M equals 7 times 9 plus 2. What is 7 times 9? 63 plus 2 more? 65. So the measure of angle M is 65 degrees. I'm going to add that to my picture right here. Then we need the measure of angle N. Measure of angle N is equal to 8x minus 3. Measure of angle N equals 8 times 9 minus 3. What is 8 times 9? 72. And 72 minus 3? 69. So the measure of angle N is 69 degrees. So I'm going to put that right here. And then we need the measure of angle O, which is 5x plus 1. So the measure of angle O equals 5 times 9 plus 1. What is 5 times 9? 45 plus 1? 46. So the measure of angle O is 46 degrees. So we're going to add that to our picture, 46 degrees. All right, time to put our angles and sides in order from shortest to longest. So I'm going to make my list for angles first. I'll have the smallest here. Then the middle one. And then the biggest. And then we'll do our list for our sides. Shortest, middle, and longest. All right, so let's start with angles. What is my smallest angle? O. So angle O. So mark this in the picture. This is the smallest angle. If angle O is the smallest angle, then what is the smallest side? NM, yes. So we're going to write that on the line, MN. Don't forget to put your segment notation over the top of MN. All right, then we want the biggest. What is the biggest angle? Angle N. So we're going to put angle N on the line. Angle N. So if angle N is the biggest angle, what is the longest side? MO. Directly across from this, right here, would be the biggest side. So MO goes over here. MO. All right, so if angle O is the smallest and angle N is the biggest, which angle goes in the middle? M, angle M. And what about the side that goes in the middle? NO, yes. NO goes right here. All right, that is the remainder of what I was asked to do on this problem. So now we are completely finished with all the examples that you would need in order to complete homework number 4. That was our last piece right there. All right. So we're going to go ahead and flip over to page 14, and we're going to start on the new material. This goes with the last homework for this module, the last regular homework of the semester that you guys will get in class tomorrow, and it will be due on Monday. We're going to talk about the Hinge theorem. Oh, that's not what I wanted. There we go. Talk about something called the Hinge theorem. I want you to think of a door hinge. Looking at the included angle. So if you have, let's see if I can draw a picture here. Remember, this would be the included angle here. think of something opening and closing, and there's a hinge back here that's holding those two pieces together. That's why this is called the hinge theorem. So we're going to be looking at the angle that's formed when you open or close this door. If two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. All right, so we have two sides of one triangle congruent to two sides of another triangle. Included angle in the first triangle is larger, then the third side of the first triangle is longer. So I want to draw a picture here to try to illustrate this point. All right. Try to do a halfway decent job here. So there's one triangle. All right. And we'll call this our second triangle. So if I have that this side of my first triangle is congruent to this side of my second triangle, and the left side of my first triangle is congruent to this side of my second triangle, we're going to say, we're just going to make up numbers here. We're going to say this is 70 degrees right here. And we're going to say that this angle right here is 40 degrees. This is the included angle because it's in between the two sides. Which triangle has the bigger included angle? The one on the left or the one on the right? Left. This right here is the bigger included angle. So that means this side right here would be the bigger third side. This angle is the smaller included angle. So this side over here would be the smaller third side. Notice these two sides of this triangle are congruent to these two sides. The angles in between are not the same size, so the third side of the triangles are not going to be the same size. You have to have two congruent sides to do this. But between the two triangles, I know that this side here would be bigger than this side over here because this angle is bigger than this angle. All right. Let's see if we can use the hinge theorem now to solve a couple of problems. I'll leave this up on the screen before I go to the next one for just a little bit longer so that everybody that needs to can get this copied into their notes. Leave it up for just a little bit longer. All right, let's go look at these examples now. Number one, part A. See, number one says compare the following sides for each picture with a reason why. We are going to compare sides BC and YZ. And notice it doesn't have the segment notation over the top because we're comparing their sizes. We are comparing their sizes. All right, so let's see. I see a congruence mark here and a congruence mark here. A congruence mark here and a congruence mark here. So two sides of one triangle are congruent to two sides of the other triangle. The angle in between the two sides on the first triangle is angle A. It's 43 degrees. Do we know how big the angle that is included in between the two congruent sides is over here? No, we would need angle X, and I don't know how big angle X is. Do I have the ability to find it?
Yes.
How can I do that?
Add angle Y, angle Z, plus X equals 20.
Yes, so 63 plus 74 plus the measurement of angle X equals 180. What do we get when we combine 63 and 74 together? 137 plus the measure of angle X equals 180. Then I'm going to subtract 137 from both sides. What is the size of angle X? 43 degrees. So I'm going to add that to my picture. This is 43 degrees. What do you notice about angles A and X? They're the same. They're congruent. Well, so which one of these two sides would be bigger if those two angles are the same? Or would they're the same size? If my angles that are included are the same size, and I have two pairs of congruent sides, then the third sides would also be congruent. So what I'm going to write on the line is that BC, the length of BC, is equal to the length of YZ. The length of BC is equal to the length of YZ. Yep. Because the measure of angle A is equal to the measure of angle X. They're both 43 degrees. So technically these triangles are congruent by side angle side. So we could even use CP, CTC here to show why those third sides would be congruent. There you are. All right, let's look at B. Let's look at B. I see a congruence mark here on QS, and it's congruent to this right here, SR. But if we're going to use the Hinge theorem, I need two sides of one triangle congruent to two sides of another triangle. Where could I get my other side from? What'd you say? In the middle, PS. It's a shared side, so it belongs to both triangles. So it is congruent to itself. So we're going to mark it with a congruence mark. The included angle on the left-hand triangle, here's my two marked sides. So the included angle would be this one right down here, which would be angle S. It's 81 degrees. Sorry, not angle S, angle QSP. Angle S isn't clear enough. QSP is 81 degrees. The included angle on the other triangle in between my two marked sides is going to be this angle right here that's right next to the 81 degrees. What do we call the angles that are side by side like that? Linear pair. And linear pairs add up to 180. So I can do 180 minus 81 to find that angle. What is 180 minus 81? Put it in your bag. How much? 99. So this angle right here is 99 degrees. Which of the two included angles is bigger? Left one or right one? Right one. 99 degrees is bigger. So which of these two sides, RP or PQ, would be bigger? RP. Here's my bigger included angle. Let's label that bigger included angle. So that means this side right here will be the bigger third side. So I'm going to write down RP is greater than PQ. RP is greater than PQ because the measure of angle PSR is greater than the measure of angle QSP. 99 degrees is greater than 81 degrees. All right, last one on this question, part C. I have two congruence marks on here. One here and one here. Where can I get my other congruence mark from? Yes, TV, this shared side right here. The angle in between these two marked sides on the left-hand triangle is going to be this 45 degrees. That's my included angle. For the other triangle, here's a marked side, here's a marked side. This would be the other included angle, but I don't know how big it is. Can I figure it out? Yeah, let's go ahead and do that. So we're going to do 75 plus 35. Plus the measure of angle UTV. We're going to equal that to 180. Then we'll combine our like terms. What is 75 plus 35? 110. Plus the measure of angle UTV equals 180. Then I'm going to minus 110 from both sides. So how big is angle UTV? 70. So I'm going to put 70 degrees right here. Which included angle is bigger? Yeah, UTV, the 70-degree angle. So which of these two sides, UV or VW, would be bigger? UV would be bigger. This is my bigger third side because it is opposite the bigger included angle. So I'm going to copy down the two segment lengths from up here, WV I copied down right here, UV I put here. Alligator should eat which one? Which one is the bigger one, did we say? UV. Alligator eats UV. So I'm going to put a less than sign in here so that it's eating this one. So far, so good? All right. Let's go look at example number 2. Example number 2 says 2 families set sail on their boats from the same dock. The Ngayans sail 3.5 nautical miles north, turn 85 degrees east of north, and then sail 2 nautical miles. So let's find them on the map. That would be this described triangle. The Griffins sail 3.5 nautical miles south, turn 95 degrees east of south, and then sail 2 nautical miles. That would be this down here. At this point, which boat is farther from the dock? Explain your reasoning. So, do I have 2 congruent sides between these 2 triangles? Yes, 2 nautical miles, 2 nautical miles, 3.5 nautical miles, 3.5 nautical miles. I need the angle in between, so I need this angle, and I also need this angle. Those would be my included angles. I don't have any angles inside this triangle, but I do have this angle out here. What do we call this pair right here? Linear pair. So let's figure out how big that angle is. Oh, thank you. Linear pairs add to 180. So I'm going to do 180 minus 85. What is 180 minus 85? I'm sorry, how much? 95, thank you. So we're going to put 95 degrees here. And we said that this was the Engaians. And then down here on the bottom, the outside angle is 95 degrees. So I'm going to do 180 minus 95. Well, what is 180 minus 95? 85. So this angle here will be 85 degrees. And this one is the Griffins. So which side is bigger? And you can give me letter names. We have NL and LG. Which of these orange sides would be the bigger side? NL. Across from my bigger angle will be the bigger third side. There's my bigger third side. So this one here is the smaller third side. "95 degrees is greater than 85 degrees. So by the Hinge theorem, NL is greater than GL. So who is farther away from the dock? If the dock is here at L, and N is where the Engaians are, G is where the Griffins are, who's farther away from this dock? The Engaians. The Engaians are farther from the dock. Right. Let's flip the page over. I'm going to go to page 15 and talk about the converse of the Hinge theorem. Converse of the Hinge theorem. If 2 sides of a triangle are congruent to 2 sides of another triangle, and the third side of the first triangle is longer than the third side of the second triangle, then the included angle of the first triangle is greater than the included angle of the second triangle. So 2 sides are congruent to 2 sides. Third side of the first triangle is longer, then the included angle of the first triangle is greater. Let's draw a quick picture to illustrate this. All right, so there's one of my triangles. And there's my other triangle. All right, so the bottoms are congruent. And then these sides are congruent. We're going to pretend that this is 15 and this is 8. So this is very clearly my bigger third side. This one would be my smaller third side. That means this angle right here would be my smaller included angle. And this angle right over here would be my bigger included angle. Leave this up for a moment while you guys get that into your notes, and then we will do a couple examples using this converse of the Hinge theorem. All right, look down at example number 3 now. Find the range of possible values for x. And x is part of this angle measurement for this angle right here. Do I have 2 pairs of congruent sides between these 2 triangles? Yes, we have this side is congruent to this side. Where's my other pair of congruent sides? HE, this shared side right here. Perfect. So this would be an included angle, and this would be an included angle. Which of the third sides is bigger? This side is the same as this side, so those are the same. JE is the bigger one, yes. JE is the larger third side. GE is only 7.3, so this is the smaller third side. So which angle, 68 or 3x plus 45, would be the smaller angle? 68. It's opposite the smaller of the 2 sides there. So this is my smaller included angle. That means this one over here would be the larger included angle. We are supposed to find the possible values, the range of possible values for x. Whenever you see a range of values, the answer will be an inequality. Answer will be an inequality. When I'm thinking about a range of values for angles, can we have angles with negative measurements? No. So 0 degrees is definitely the smallest. All angles inside a triangle have to be bigger than 0, but they all have to be smaller than what? They don't have to be smaller than 90, but you're on the right path. 180. 180 is a straight line. That would not be like an angle in the classic sense. So all angles inside of a triangle have to be between 0 and 180. If I can get more restrictive than that as I'm trying to answer this question, I will. If I can get more restrictive. We know that this is the smaller included angle, right? This angle over here has to be bigger than 68. So I'm actually going to replace this 0 here with a 68 degrees. This is smaller than the other angle. So 68 degrees is less than, I'm going to put my other included angle here, which is 3x plus 45. And that would still have to be less than 180. I know this one is smaller than this one, but I don't know anything that's bigger than this one. So that's why I left it as 180 over here, because I don't know anything that's bigger. Have you guys solved double-sided inequalities like this before? Maybe you've seen this in Algebra 1. So what we're going to do is we're going to draw little fences here where my inequalities are. Does that look familiar? All right. We're going to work from the middle out to both sides. So as I'm looking at this right here, if I want to solve it for x, what's the first thing I would need to get rid of? The 3 or the 45? 45. What operation would let me get rid of the 45? Subtraction. So I'm going to minus 45. But if you do it to one side, got to do it to the other side. In this case, I have two other sides, so I have to minus 45 from both of the other sides. All right, so what is 68 minus 45? 23. So I have 23. I'm going to bring down my inequality here. The only thing I have left in the middle is 3x. Bring down this inequality here. What is 180 minus 45? 135. How do I get rid of that 3 that's in the middle? Divide. And if I divide in the middle, where else do I need to divide? Yes, the other two sides. We're going to divide these sides by 3. If I do 23 divided by 3, does that come out to be a nice, pretty whole number? No. So I can either leave my answer in fraction form. I could have 23 over 3. Or I can change it into its decimal form. Does anybody happen to know what 23 divided by 3 is in its decimal form? Yes, so 7.6 repeating, right? Because it's 666666666 off the screen. All right, bring down that inequality. X goes in the middle. Bring down my other inequality. Can I divide 135 by 3 evenly? What do I get when I do 135 divided by 3? 45. That one came out pretty, so I'm just going to leave that as 45. Either one of these would be a correct final answer. Unless the directions say you have to leave it as a fraction, I don't care whether you write it as a fraction or as a decimal. So far, so good? All right. I think we're going to leave the remainder of these examples to do tomorrow after we finish grading your homework. So first thing we will do is grade homework number 4. If you don't have a copy of homework number 4, I still have copies over here, very bottom paper. That is due at the beginning of class tomorrow. And then we will do the remainder of your packet with the last homework being due on Monday.